Okay, so are you ready to dive deep? Because today we are taking on a paper that is basically legendary at this point. It's called Attention is All You Need, and it's all about AI.
Yeah, this paper really did kind of change the game, didn't it? I mean, we are talking about the birth of the transformer model here.
Which I'll be honest, when I hear that name, like I immediately think of giant robots. But before we all get carried away thinking about Optimus Prime learning grammar and stuff, let's talk about why this paper is such a big deal. Even if you aren't, you know, a coding expert.
Yeah, for sure, because this is really about how machines actually process language. And honestly, that impacts pretty much everything we see in AI now. I mean, think about it for a sec. If you want to get a computer to translate languages or summarize text or even just figure out what you're asking in a search bar, it all goes back to understanding words in a sequence.
Oh, okay. So like when you want to take a sentence in English and turn it into French, or when you want to take a super long article and like pull out all the main points, that's what sequence transduction is.
Yep, you got it. And actually, before the transformer came along, the tools for doing that were, they were decent, but they had some serious limitations. Imagine trying to read a whole book, but like only one word at a time. And you can only remember the last couple words you've read.
Oh man, that would be so frustrating.
Mm,
Like trying to solve a mystery, but you can't remember any of the clues.
that's basically what those older models like RNNs had to deal with, processing things sequentially word by word. And that created this like bottleneck. It was super slow and it made it really hard to train them on huge amounts of text data. And oh boy, did they ever struggle with those long range dependencies.
Okay, wait, hold up. Long-range dependencies. That sounds kind of technical. What are we talking about here?
So it's about those times when the meaning of a sentence kind of hinges on words that are really far apart. Like, let me see. The cat who loved napping in sunbeams and chasing butterflies finally caught the elusive red laser pointer. That whole first part is all about the cat, right? But the whole point of the sentence is way at the end.
So are you saying those older models would basically forget that the cat even existed by the time they got to the laser pointer?
Pretty much. And that's a huge problem if you want to build a machine that can really, truly understand language, not just kind of stumble through it one word at a time. This was like the big roadblock that everyone kept hitting until attention is all you need came along and just like blew everything wide open.
So that is where this like superstar model, the transformer, comes in, right?
Yeah, exactly.
But they didn't just like try to make those old models better. They basically threw out the whole playbook and started over.
Yeah, it was a radical move for sure. Instead of just relying on, those kind of clunky step-by-step approaches with the transformer, it was like they said, what if we just let the model focus on what's important, like our brains do?
Okay, I like that idea. But how does a machine even do that? Like
Yeah.
this whole attention thing, are we saying the transformer is actually concentrating?
In a way, yeah, kind of. Think about how you read like a news article or something. You probably skim some parts, right? And then you focus really hard on other parts, and maybe you even go back and reread a sentence that seemed important. So you're shifting your attention around based on what you think is important to understand what you're reading. The transformer basically does the same thing, but with data.
So it's like instead of getting bogged down by every single word, it just picks out the ones that really matter.
Exactly. And it does that by calculating all these relationships between the words, even if they're super far apart. And this is where that scaled dot product attention comes in. But don't worry, the name is way more intimidating than the actual concept.
Please tell me this thing isn't actually doing like complex math problems for every sentence it reads.
Well, there's definitely math involved. But okay, think of it like this. Imagine you're searching for something online. So the search engine takes your words right and it compares them to literally billions of web pages. And then it shows you the results that it thinks are the most relevant.
Right, it finds the best matches.
That's basically what scaled dot product attention is doing. But instead of matching your search to a web page, it's figuring out which words in a sentence are like the most related to each other. It's like giving each word a relevant score based on every other word in the sentence.
Okay, so if we go back to that cat example from before, the transformer would be able to see that cat is connected to chasing and laser pointer, even though those words are kind of far apart. No more forgetting about the cat.
Exactly. And here's the really cool part. Because the transformer isn't stuck going like word by word, it can process all of that at the same time. Remember that bottleneck we talked about? Gone. This is what makes it so fast and so efficient, especially when you're dealing with these massive data sets.
Okay, this is seriously blowing my mind. But it gets even crazier, right? Because then they start talking about multi-head attention in the paper. Are we about to like enter a sci-fi movie or something?
Well, maybe not a movie, but it is about taking the power of the transformer and like multiplying it. Imagine if instead of having just one expert analyzing that cat sentence, we had like a whole team of experts all looking at it at the same time.
Okay, so we've got one expert who's like the grammar guru, making sure the sentence actually makes sense. And then another one is analyzing the emotional tone. Like, is this cat being playful or is it annoyed?
Exactly. And then maybe you have another one that's keeping track of all the objects and the actions, like the cat, the chasing, and the laser pointer. By combining all of those different heads of attention, the transformer can get this super nuanced understanding of the text.
This is where I always have to ask, like, how do people even come up with this stuff? It's genius.
It really is. But what's even more amazing is what they discovered about this self-attention.
Self-attention. So did they like want to make the transformer introspective or something? Like make it analyze its own thought process?
That's actually a really good way to think about it. What they found was that when they let the model compare different parts of the input, like our cat sentence, it unlocked this whole other deeper level of understanding. It's like the sentence is having this conversation with itself to figure out how all the words are connected.
I love that. The sentence is its own detective. But okay, seriously, how big of a deal is this self-attention thing?
It's a really big deal. Remember how those long-range dependencies were like a tripwire for all those older models? Well, self-attention is how they solved it. It's like they gave the transformer X-ray vision. Suddenly it could see those connections no matter how far apart the words were.
No more lost cats and forgotten laser pointers then. But didn't they have all those tables in the paper? All the
Yeah.
data to back this stuff up.
Oh, yeah, for sure. Like Table 1, for example, that's where they really show you how much better the transformer is. They compared it to those older models, and it just like blows them out of the water in terms of speed and efficiency, especially when you start looking at longer and longer pieces of text. Kind of embarrassing for the other models, to be honest.
It's like they brought a horse and buggy to a spaceship race. But they didn't just stop there, right? This wasn't just like a theoretical exercise. The transformer had to prove itself in the real world.
Oh, yeah, definitely. That's where the WMT 2014 benchmark comes in, which is basically like the Olympics of machine translation. It's a super tough test they use to see how well these models can actually translate between different languages.
Okay, so how did our superstar transformer do? Drum roll, please.
It crushed it, like absolutely destroyed the competition. We're talking record-breaking performance here. And Table 2 is where they show all the receipts. Significantly more accurate translations, and it often did it in way less time than any of the other models. It was like undeniable proof that attention is all you need wasn't just a catchy title, it was the future.
Yeah, better translations are obviously a huge deal. But the paper mentions that they think this could go way beyond just language. Didn't they say they were already thinking about using it for things like images and audio and even video?
Yeah, they did. And it makes sense that they were so excited about it because what the Transformer really shows us is this fundamental shift in how we can build AI. It's like they cracked the code for how to teach machines to focus on what's important, to see those connections that make information meaningful, and it doesn't matter if it's words or something else.
So when we talk about the impact of this paper, it goes way beyond just those impressive results they got. It's like they gave every AI researcher this brand new toolbox to play with.
A toolbox that led to some really amazing breakthroughs, to be honest. I mean, think about it. Without the Transformer, we wouldn't have ChatGPT or BART or so many of the AI tools that we relied on every day.
It's kind of wild to think that a single research paper could cause such a massive revolution. I guess it really is. Attention is all you need.
Yeah.
Not just in AI, maybe in life too. Learning to focus on what matters, making those connections.
That's a great point because ultimately understanding how the transformer works isn't just about understanding the technical details. It's about appreciating the power of attention itself. It's what lets us understand the world around us. It's how we learn new things and it's how we create.
And who knows, maybe as AI keeps evolving, it'll even be able to teach us a thing or two about how to pay attention better, how to find those hidden connections in our own lives. Definitely something to think about. That's all the time we have for today's deep dive. Thanks for listening. And until next time, keep exploring, keep questioning, and keep paying attention.